So in part C of the problem, we're asked to figure out how high the block will rise above the highest point reached by the platform. So let's start off by figuring out what the velocity of the block is right when it leaves the platform. So we'll call that v. And that's going to be given by y dot, which from part A is omega times a cosine omega t. Now, by our trigonomic identities, we know that cosine squared plus sine squared is equal to 1. So that means that cosine is equal to 1 minus sine squared. So this is equal to omega times a cosine omega t, which is equal to a squared minus a sine omega t all squared, all to the 1/2. So that just follows from a trigonomic identity. Now notice that a sine omega t is y, so here we have omega times a squared minus y squared all to the 1/2. So if we plug in our value for y from part B, we'll get that the velocity when the block leaves the platform is going to be omega times a squared minus, here in brackets we're going to have g over 2 pi nu, which we're going to call omega. So that's omega squared, all squared to the 1/2. So now that we know the initial velocity, we can figure out the height. Since after the block leaves the platform, the only force on it is going to be gravity, so the vertical acceleration is going to be given by negative g, which is a constant. So in this case, we'll use our equations of motion for constant acceleration. So we'll use the fact that the initial velocity squared is going to be, or the final velocity squared is going to be equal to the initial velocity squared plus 2 times the acceleration times the distance the block travels. So we'll call that y, or y max. So if we solve for this, we get that y max is going to be equal to the final velocity squared minus the initial velocity squared over 2 times the acceleration, vertical acceleration. Now the final velocity when the block reaches its maximum height is just 0. So that's just 0 minus its initial velocity, which is v. That's v squared. And that's going to be over 2 times its vertical acceleration, which is negative g, so negative 2g. So the negatives are going to cancel out, and we're going to get v squared over 2g. So that's going to be omega times a squared minus g over omega squared to the 1/2 over 2g. And if we expand that out, we're going to get, so this should be all squared. So if we simplify, we're going to get omega squared times a squared over 2g minus g over 2 omega squared. Alright, so that's going to be the vertical distance from the midpoint that the block will rise. So the total height that the block will travel compared to the highest point reached by the platform is going to be y max minus a, since a is the amplitude of the motion of the platform, which means that the highest point reached by the platform is a. So this means that h is equal to omega squared a squared over 2g minus g over 2 omega squared minus a. If we plug in for omega, which is 2 pi mu, we get that our final answer is 2 pi mu squared times a squared over 2g minus g over 2 times 2 pi mu all squared minus a, which if you simplify that is going to be 4 pi squared mu squared a squared over 2g. So that's going to cancel out and give us that over g minus g over 8 pi squared mu squared minus big A. So that's our final answer for part C.